Okay, so we're going to talk about kind of the concepts that you need to understand behind when you're solving trig equations with limited domains. Um, so it's all about looking in that particular window of where a problem occurs. Um, the unit circle where we know the values of things are in this range, right, between 0 and 2 pi. You'll see this used quite often, although it's not the only limited range that you'll see. Sometimes it could be anywhere. Um, but you're going to use what you know about coterminal angles to answer outside of that. So let me draw the curve for for cosine. So cosine is going to look something like this. Okay? Well, on the unit circle, you know the unit circle, the values of cosine from here to here. Okay? Now, if they asked you, let's say, for example, what's the they asked you to answer in a different range, you would need to use your ideas of coterminal angles. So if they said, where is the sine, or excuse me, where is the cosine for, let's say the cosine of x, or the cosine of x is 1/2. But your range that they're giving you is going to be negative 2 pi to 0. Let's say that they answered that way. Well, when is the cosine 1/2? So we got to think about our line. So cosine's 1/2 in these two places. Not a perfect graph, but it's going to be at pi over 6 and 5 pi over 6. Or excuse me, no, pi over 3 and 5 pi over 3. So this is pi over 3 and 5 pi over 3. Well, we don't know that we can't answer in that range because that's not what they're letting us do. We can't answer that because that's not allowed, right? We have to answer from negative 2 pi to 0. So we have to translate those. So we need to find these. Because this is a pretty simple function, this is the typical cosine graph, all you need to do is find the coterminals of that. Okay, so what you do is you are going to subtract 2 pi. So this one goes with this, you subtract 2 pi away, this one goes with this. So when you take 2 pi away from each of these, this will be negative pi over 3, and this will be negative 5 pi over 3. This works, you may see a pattern here. This works for cosine because it's symmetric. But these are the answers that you're going to look for, right? The other two are going to be used for you. You're going to relate those back to the answers that you need. So you just need to make sure that you're answering only in those ranges and not outside of it. Now, let's say we had something with multiple angles. Now, how does this differ? Okay, and this is interesting. Let's say we take the same thing for cosine. So cosine, we said, was like this. Okay, well, what if I did the cosine of 2x? Okay, so the cosine of 2x. Well, that means it's getting done the same amount of it's doing twice as much in the same amount of time. So I'm getting things like something like this, right? Where I've got 3 peaks instead of 2. I've got 2 valleys, or 2 bottoms or minimums instead of 1 in the same amount of time. So when we take that back, what we can do is we can think of this as a stretched out version of itself. And what I mean by that is that instead of looking at a limited range, we can think of it as kind of maybe a little bit more expanded. The first one had 1, 2 zeros. So that had 2 answers. If we were to look in from 0 to 2 pi. So let's say we're looking from 0 to 2 pi. Well, look at how many answers we have for cosine of 2x. We've got 1, 2, 3, 4. 4 answers. Okay? What we can do is think about stretching the circle out, doing things twice. And so you're going to end up with double the amount of answers. Now, whatever this number is will be the multiplier of the number of answers you would normally have. So if let's say you had, so let's see, if we had the cosine of x equals 1/2 has 2 answers for the unit circle. So this is all based off of 0 to 2 pi. Well, the cosine of 2x equals 1/2 has 4 answers. Let's see, the cosine of 7x, for example, equals 1/2 is going to has 14 answers. And let's say, what about the cosine of 1/2 x, or x over 2? Well, that's just going to have 1 answer. It's all this multiplier. And it's because it's the number of things that are occurring before it gets there. Now, obviously, we can't go below that, right? If we did x over 3, we may not be able to create 2/3 of an answer. So you'll see these numbers come up quite a bit, and you just got to understand that the bigger the multiplier here, the more answers that you're going to have, just like you will have with fewer answers. Now, what you want to do with this is, let's say, it doesn't really change the way the problem works. The cosine of x equals 1/2. If you were to look on the unit circle, and let's say we said between 0 and 2 pi, this answer, so x is going to be pi over 3 and 5 pi over 3. Okay? Well, if you did the cosine of x equals 1/2, the cosine of 2x equals 1/2, you would end up getting 2x equaling 2 pi over 3 and 5 pi over 3. Now, with this, you are going to divide by 2. But that's not the only difference. Because, remember, twice as much is happening inside of this range, right? So, we don't have the 4 answers that we are expecting. We need to create more answers. So we need to create more coterminals to that. Okay? We know that we have 4 answers. So, because of this 2. So, so our coterminals to these would be adding 2 pi to them. So when we add 2 pi to those, we get 7 pi over 3. And we also get 11 pi over 3. So you may say, okay, that's a little more complicated. How do I remember this? Well, in some of the other videos I've shown, how to add the angles and stuff. Just basically what you need to do is double this bottom number and add it to the top. Add it to the top, right? So we double that and add. But we need to have 4 answers because of this, okay? Now, you'll see that in a second, because when I divide everything by 2, I'm going to end up with x equals, so pi over 3 divided by 2 is pi over 6. 5 pi over 3 divided by 2 is 5 pi over 6. 7 pi over 3 divided by 2 is 7 pi over 6. And 11 pi over 3 divided by 2 is 11 pi over 6. So you see that because I just need my x just has to belong to here, okay? Not 2x. 2x doesn't have to belong to 0 to 2 pi, but x does. So that's why we kind of double the number of answers that we have because we have another entire rotation that we haven't normally accounted for. But when you write out those coterminals and then divide, you see that all of these are nicely fit inside of this.